In this video clip, we will talk about the definition of odd function. Previously, we have talked about the definition of even function and also the graphs. We know the typical example was f of x equals x squared. And for example, when you plug in -2 here, you have a -2 squared is 4. When you substitute +2 for x, then you have a 2 squared is also 4 as well. So those two values are equal, then those two values are equal. So it tells us f of -2 equals f of 2. Okay? And here is the general one. General formula. Okay? And then the graph is actually symmetric with respect to y-axis. That's for even function. Now today is different. Is f of -x equals -f of x. It appears this negative sign can get out, which is different from here. F of x, f of -x equals f of x. That was the case. I will leave this example for readers, and then I will actually do this example. For example, f of x in this case can be 1/x. If we plug in, let's say, -2 here, we then have a 1/-2, which is -0.5. -1/2 is -0.5. If we plug in 2 here, so we then have a 1/2, which is +0.5. And then we can see if we put negative sign everywhere, and then it will make those two equal. And then here we can see is that those two values are equal. F of -2 equals -f of 2. Okay, that's the case for this example special values. In general, how we are going to do with this one? In general, we can prove in this way. So you see right here, we plug in f of -x. We plug in -x over there. Here was x. Here would be x. If we plug in negative there, then the case is going to be 1/-. And then, which is -1/x. And remember, this was our f of x. Right here you can see clearly. F of x is 1/x. So this basically tells us -f of x. Then we have proved is f of -x is -f of x. So this function is odd function. Okay, so how does the graph look like? Let's move on. Okay, so here is the case. The graph is right here. Again, you may look at that. We did that previously, 1 minute ago. Okay, and we said that we have calculated f of 2 was 0.5, f of negative 2 was negative 0.5. Basically, we have 2 points on the graph. When you connect these 2 points, you will see those 2 points are symmetric with respect to the origin. Actually, every pair of points has this property. If you connect those 2 points, then the line will go through the origin. And the distance between the origin and this point equals the distance between this point to the origin. So those 2 points are symmetric with respect to the origin. So are the cases for this point and this point. When you connect those 2 points, the line goes through the origin, and this distance equals this distance. So then when you rotate this line 180 degrees, you will see this point actually goes here, and this point actually goes here. Let's look at the animation graph. Okay, so here is the one. You see, you connect those 2 points. This is the dotted line, goes through the origin. Those 2 points are symmetric with respect to the origin. Actually, every pair on the line, on the graph, are actually symmetric with respect to the origin. Those 2 pairs and those 2 pairs. When you rotate 180 degrees, you see those 2 points exchange the position. So since every pair of the points has this property, so the graph, when it rotates 180 degrees, the graph will coincide to the original graph. So readers may play that. You see, like that. So the graph of odd function is symmetric with respect to the origin. Please rewind this lecture. I'll see you next time.